5 years back, we decided to conceive a new group project for the students. At that time, the computer science students and the computer engineering students did their separate practical projects. And we decided to combine these groups and the double degree students together to do a multidisciplinary project. In the real world, when you go out to work, it's seldom so clear-cut, and you often need to work with team members. And that's why we decided to combine all our programs into one.
I'm the coordinator for this MDP course, which consists of both computer science and computer engineering students. This system integration course, which students coming from different backgrounds working on this as a group to undergo several experiences.
Everybody takes a different role and they have to share what they are developing, how each and every sub-component going to interact with each other.
Because of the multidisciplinary nature, we decided to choose a robotic challenge for the students to work on. You get both the hardware and software and the integration of both to solve specific problems. We have a common first year for both our computer engineering and computer science students, but from then on, they actually have their respective differentiation. Only third year students are eligible to enroll for the MDP. So by then, they would have done at least 4 semesters of courses.
Please move back. And we tend to keep the lectures very early such that the students will have a head start on what they need to do in the later weeks. 4 lecturers who would be talking about 4 different aspects of this cyber-physical system, which we call to be the super system integrating 4 different subunits.
They made us attend a few of the lectures that they had given the students. We got to be in the shoes of the students. We knew what was coming for them and we could guide them accordingly. So that was a really good thing that the faculty did. And along the way, they were always there with us to guide us, to advise us.
During the first few weeks, we actually have specialized lectures for us where each individual sub-team, in total we have 4, Arduino, Raspberry Pi, Android and algorithms. So what we do is we attended each of the specific lecture that the team we are in, and we will be learning a lot from lecturers, and we are implementing some of the theory that the lecturers told us into our codes.
Everybody has to keep it at this time, so there's no manipulation. We divide them into 4 labs and place 7 groups in each lab. Each group would contain 8 members, 12 faculty members, 3 faculty for each lab will be there throughout the 13 weeks.
I'm one of the supervisors. Being a hardware engineer, and I take the role and responsibility of hardware integration. So I do spend time with individual students on how they can integrate the robot and what robot can do.
We take a very hands-off approach because we shouldn't be sitting there and trying to figure out with the student why their program is not working. We can give them broad guidelines and ask them to do experimentation, and we point them to the resources they can have. We have a mobile robotic challenge. Basically, we provide students with a maze in which the robot had to autonomously navigate within this maze. And every week, the obstacles are placed differently. So the robot has to navigate through the maze, find out all the obstacles, and then go from the start position to the goal position in the fastest possible way.
The school structured this course in such a way that they are encouraged a healthy competition among the different project teams. By weekly competition at the end of every Friday, it's like the maze runner. That is the first real problem that we are trying to solve by applying what we have learned. We are given a target, but there's no specific guidelines. It's pretty similar to the professional space whereby when the managers or the seniors gave you a task and you need to figure out what to do from scratch.
Exploration, 3, 2, 1, go!
You can see the joy and the disappointment in the students, and this kind of gives us a sense that they are being engaged in their learning. The students realize that even though they have finished their projects, there are other teams that have done better than them. This actually provides the kind of real-life scenarios for our students where if you go out to work, every time you think you are good enough, somebody else come up with something better. That lab itself is actually a one big team because whenever one robot starts working in that lab, we start to see the other teams, their robots are also starting to work. Obviously, they are sharing, so it's very useful sometimes to make students work in close proximity because that they really learn from each other.
There are many ups and downs, but at the end of it, when you look back, I think the journey is quite enriching. We learn a lot of things that we wouldn't know, like how important it is to start integration early, how important is communication, how important it is to not be discouraged after every failure. I think those are the things that it's not intended, it's not part of the course structure or anything, but it's the intangibles that actually matter more.
So one of the features of MDP is that they learn how to use devices. It's used by the makers communities who are experimenting with their own ideas. This is a Raspberry Pi 3.0. What we wanted our students to know how to use devices like this, and then if they have their own ideas, they can actually take it beyond MDP and use this to build their prototypes, to show people their ideas into workable systems. The students do a fair bit of programming in Python and in Java, like Android programming. And they also learn about algorithms. There they get to put their human-computer interaction principles into practice. So these are some of the examples how we get them to apply what they've already learned.
So during my internship, I was exposed to a new programming language, and I was asked to develop a system that I haven't thought I should develop. What I've learned from this MDP actually helped me break it down to a small phases, and then we get through it.
So there's a lot of very practical new knowledge that they pick up. So the purpose is actually for them to do things with their hands. And many of the opportunities to learn is actually online. We point them in the right direction, and many of the learning they do is through tutorials they can find online and to experiment. So that's the other way that they learn.
It stands out from routine courses. It really teach you something that the standard lectures that didn't teach you, like in terms of how you pick up the new skills or knowledge independently, how you work in a stress in a tight timeline. All these so-called like the survival skills in the workspace, right? You would hardly learn from other courses.
A lot of people before that don't really know what domain of interest they have in computer science. So MDP provides a very, very real application of all the things that they have been learning, and then they use that for their FYP. So MDP sort of helps you figure that out, I think.
Shorter path. 3, 2, 1, go.
As an engineer, you must learn how to learn. It's not about learning a new framework, learning a new technology. It's your ability to learn and adapt quickly